Okay, today's run through is going to be an IGCSE Edexcel paper for physics and double science students, paper 1, and it's from last summer. So it's quite a recent one. So it's the May 2024. So I've got my model answers, and interwoven with my model answers, I'll show you the mark scheme. Okay, so remember, for these exams, you need to bring your protractor if they ask you to measure any angles, and you need to know how to use a protractor. Okay, obviously you need a calculator, and they're going to give you an equation booklet, which they've started giving since COVID. So you don't have to remember your equations, but you need to know how to use them and how to change the subject of the equation. Okay. Obviously you also need a ruler. So this is the original list of formulae they used to give before COVID, and that's all you had. Okay. Now they give this equation booklet. This is what they gave last May in 2024. And this is for paper 1, the first few pages. So the equation booklet is separate to the exam question paper. Let's have a look at it. So it says the equations may be required for GCSE physics, yeah? I mean IGCSE, and the GCSE combined science papers. So this is for paper 1. So forces and motion, the equations you need to know how to use. They're given it in word equations, and then they're given it in the symbols. Okay, remember that these are SUVAT, V-U-A-S, V and T. S, so that's what they call SUVAT, S-U-V-A-N-T, and S is distance, and U is initial speed, whereas V is final speed. So you need to know those to be able to use them. Electricity has its own list. Waves, you need to know. Okay. And then energy, kinetic energy, gravitational potential energy, work done, efficiency and power. And then solids, liquids and gases, density, pressure, pressure difference due to being under a fluid of density, yeah, P equals H rho G. So that pressure increases with depth. For example, in the ocean, the fish are underneath a certain depth of water, so it adds to the atmospheric pressure above the water. Boyle's law, pressure times volume is a constant, P1V1 equals P2V2, and the pressure law, where pressure divided by temperature is a constant if you do it in Kelvin. And then the only equation after that comes right at the end in astrophysics, where you can work out orbital speed, because if it's orbiting, you know the time period is how long it takes to do one orbit, that's capital T, and the distances traveled is the circumference of a circle. We're assuming the orbits are circular. So these are the only equations you need for paper 1. Yeah, and the next page, you only need them if you're doing triple science. So these on the next page is for paper 2, physics only students. And as we're not doing paper 2 today, I will go through this in a separate run through if I do a paper 2 run through. Okay, so there's extra equations that if you're doing double science, you do not need to use these equations. All right, so back to the questions. Question 1 is on astrophysics. So that's the last topic we studied, and it's about circular orbits. Okay, the question is about the motion of objects in our solar system. So in our solar system is a star, our sun, the planets, and it wants you to draw a labeled diagram showing the moon orbiting the Earth. Okay, so they just want you to show a circular orbit. So if you can do that, we'll have a look at the mark scheme. Obviously you want the Earth in the middle and the moon going around it. So that's all you've got to draw is a circular orbit. So if you draw the Earth in the middle, yeah, and then the Moon round it, and then you try and draw a nice circle going round the Earth, yeah, there's my circle. Let's just erase the Earth now the circles come out, and redraw the Earth in the middle. So the Moon is constantly changing direction due to the gravitational force. So that's a circular orbit. Name the force. So you just got to name the force that causes the Moon to orbit the Earth. Don't write gravity, yeah? Write gravitational force, or the force due to gravity. So you've got to put gravitational rather than gravity. Okay, gravity is just the study of the subject. Okay, gravity actually is more of an acceleration if you use it as G. Yeah, G is the gravitational field strength rather than the force. Okay, so you've got to put gravitational force. All right, give the name of another object that orbits the Earth. So you could put a satellite. Yeah, so a satellite will put in by man, it will orbit the Earth. A planet and a comet both orbit a star. So now instead of orbiting the Earth, we're now looking at orbiting a star. Yeah, whereas the satellite orbits the Earth, the Moon orbits the Earth. Again, gravity is responsible for all these orbits, but we want to talk about the difference between the orbit of a planet, which is very circular, and the orbit of a comet, which is more egg-shaped or elliptical. So you need to know these. And the other difference is, if it's going in a circle, it kind of goes at constant speed, whereas if it's elliptical, it varies its speed. Because obviously as it approaches, goes closer to the sun, it speeds up. As it moves away from the sun, it slows down. So that's your first 5 marks. And here's the mark scheme. Okay, so you need to have a label diagram to get the marks. So you've got to show that the Moon is in a circular orbit around the Earth, and both must be labeled. And you've got to make sure that you draw on the Earth approximately at the center of the path. That's why I redrew mine once I'd drawn the orbit with my Apple pencil. See here, they put gravitational rather than gravity as the name of the force. See, in this case, they're allowing gravity, but it's safer to put gravitational. They will not accept weight, because weight is when you're on the surface of the object. Okay? All right, that's it. So satellite would have been okay. The other one you could put is the space station, which is also in a satellite's orbit. Okay? And that's part B. So question 2 is about radioactivity, which is topic 7, which is also kind of nuclear physics. So the nucleus of an atom of carbon, so carbon has 6 protons and 8 neutrons, and that will be carbon-14, an isotope of carbon-12, which is more common. Which row of the table shows the nucleus of an atom that is a different isotope of carbon? So to be carbon, the number of protons must stay the same, so it's got to be 6, but the number of neutrons must be different, so it can't be 8, because 8 is for carbon-14, and they want a different isotope, so you've got to figure out that it has to be B. Okay? So B, A is the answer, And you got to put in your x in the space provided. So you have to try, and I can't do it with my Apple Pencil very easily. You've got to draw it carefully in the space provided. Part B of this question says, which type of radiation is a high energy electron? Well, alpha is 2 protons and 2 neutrons. Gamma is, the answer is B. It's a fast moving electron. This is just a knowledge question. Gamma is not even a particle. Gamma is equal to electromagnetic radiation. It's like a high energy X-ray. And a neutron is obviously not an electron. Okay? So a neutron comes from a nucleus. So the answer is B. And you just got to know that. High energy, fast moving, high energy. Okay? If it's high energy, if it's fast moving, it means it has kinetic energy. And then it says a nucleus emits radiation. This causes the mass number to decrease by 1. Yeah? So it's a thinking question, but the atomic number stays the same. That means the number of protons doesn't change, but the number of total number of neutrons and protons decreases. What type of radiation does the nucleus emit? So you've got to use a process of elimination. Remember, alpha is 2 protons and 2 neutrons. Well, that's going to change both the mass number and the atomic number. So the atomic number won't stay the same. So this one must be wrong. Beta, yeah. In beta, what happens is one of the neutrons changes to the proton. So the mass stays the same. Because although you got one fewer neutron, you gain a proton. So it's basically just adapting itself to its environment to become more stable. So the atomic number does not stay the same. Mass number stays the same. So it's the opposite of what they've asked for. And gamma is not a particle, so it doesn't change either. It changes neither mass nor charge. And charge, atomic number, is equal to the charge. Okay? So it's not C, so the answer has to be, by process of elimination, D. Yeah? If it emits, gives out something, and it gives out a neutron, that means the mass is going to decrease by 1. Yeah? But the atomic number, which is protons, doesn't change. Okay, so the answer is D. More difficult question than the previous two. Here we have a nucleus of an isotope of uranium-238. Yeah, and this is how you can represent it. It's the same 2 numbers you find in the periodic table. The top number is the mass number, the bottom number is the proton number. The nucleus forms part of this nucleus forms part of a positively charged ion. So to become an ion, it must lose electrons. Remember, when you lose electrons, it becomes a charged particle, and that's what we call an ion. How many electrons could be in this ion? Well, it has 92 protons. If it loses, that means it also has 92 electrons. Okay? So it starts with 92. So it must lose some of the 92. Well, it can't be 92 then. It has to be less than 92. So all of these are wrong. The answer must be 90. Question part E. A radioactive isotope has an initial activity of 400 becquerels. That's how much radiation it gives out per second, 400 bits of radiation per second. So that's its initial, means when time was 0. The half-life is 8 hours. And that means every 8 hours it's going to half. So from 400, it will go down to 200. But they want to know what will the activity become after 16 hours. Well, 16 hours is 2 times 8, so it's 2 half-lives. And every half-life, the activity halves. That's what half-life means. So after 1 half-life, it goes down from 400, half of that, to 200. And after 2 half-lives, the 200 will halve, so you get half of 200, so you'll end up with 100. So the answer is C. Okay? And here is the mark scheme. Okay? I'm going to stop the video there, take a break, and then I'll come back and do some more. So this is for the students who came in and did a face-to-face extra session with me during the week, and I promised that I'd put the answers on YouTube. So please like and share the video with anyone who didn't attend. And if you've subscribed, thank you very much. The more people see this, the more likely I am to continue to do GCSE videos, because I started the video mainly for my A-level students, and there's more demand for A-level. So if you want GCSE videos like this, make sure you show your appreciation, like every video you watch, and pass it on to any friends you have who are currently studying for their GCSEs. Okay, catch you in the next video. Bye for now.